compound inequalities, compared to what we've done in the past, they're just bigger. So they're going to require distribution, perhaps. They may require combining like terms, and then some more principles of equality, but it's essentially the same thing. Once we get to the end of the inequality, we can graph it and then write an interval for those if it's necessary. So there we go, principles of equality again. Whatever you do to one side, you got to do to the other side. We've seen this slide many times. And yes, there's just one extra rule for solving inequalities. That's it. So solving inequalities, just like we would solving equalities, distribute if it's necessary, combine like terms if it's necessary, use principles of equality to isolate the variable, and then even at the end there, step 4, divide by the coefficient. That is also a principle of equality. Yeah, there we go. If the coefficient is negative, that's the only extra rule here with inequalities is if that coefficient is negative, then flip the inequality. We said this a little bit differently the other day too. We said if you ever have to multiply or divide both sides by a negative, ever, then it will flip that inequality also, okay? That process shouldn't be new, so hopefully you see that. It's like, oh, we've seen that before. Maybe we didn't have so much experience with it, but we definitely will today, okay? So it's important to understand the difference between unions and intersections. Unions, I don't know that they're more common, but they give us a little bit more to look at, right? Because it doesn't have to be just part of one, it can be part of either one, right? So you could say, which of these sets has, does set A or B have a 1? And the answer is yes. Okay, now some people would be like, well, it's set A. That's true, but I was asking if A or B has it, and the answer is yes. Okay, you see the difference in the terminology there? Or I could say, does A and B have 1? No, A does, but B doesn't. That's an and statement. See the difference? And so does A and B have a 7? Yes, they both have 7. Does A and B have an 11? Yes, they do. Okay. So that's how this union intersection thing works. We don't necessarily look at it in set notation when we're looking at inequalities because we're only looking at one inequality at a time. And since most of these inequalities result in some form of infinity, yeah, we don't want to list these numbers. It would take longer than I want to. So solving, graphing, giving interval notation, again, nothing new, just with the last lesson we saw most of this stuff at the very end, but now we can see that it's going to require some a little bit more of what we've done already. But the good news again is that we treat these like they're equalities. It's not going to change. Nothing in the about the inequality itself symbol is going to change until the very end, at least if we follow this method, okay? So I'm going to start with the 5x minus 2 is greater than or equal to 23. And first thing, no distribution here, no combining like terms, so I just don't want to isolate my x's. And that means I got to get rid of that minus 2 right there, so we'll have to add 2, not just to one side, but to both sides right there. So that's going to zero that out just like I want. I'm going to drop my negative 5x. Does not change the inequality, but 23 plus 2 is 25. Then we'll divide both sides by the coefficient, negative 5. And here we go. The coefficient was negative 5, and that's the last step. It is the negative, which means that the inequality is going to need to flip on this one, okay? Maybe I'll color that a little bit different, but now I'm left with x. You can say phantom 1x if you'd like. But x is now less than or equal to what results is, looks like negative 5 here, okay? So right now, x is less than or equal to negative 5. Or, and this is where this other statement comes in, and we got to solve this one too. So with this one, there is distribution. So let's go ahead and, distribute 4 here. So that's 4 groups of 1x, which would be 4 x's. And then that's also 4 groups of negative 4, which would be negative 16. Nothing else there really changed. But now we're looking at the same type of equation that we just barely saw. I need to isolate my x's because there's no like terms to combine. And so that would be plus 16 on both sides. Zero those out, drop your 4x, which is now less than. Negative 8 plus 16 is positive 8. And then finally, we'll divide both sides by the coefficient 4. Now this coefficient is positive, so it will not flip the inequality. You just get x is less than 2, okay? So 2 inequalities here. X is less than or equal to negative 5. And this is an important thing to do. at least when we have an exam on this kind of stuff, you gotta put an or statement in between the two. Some students in the past have used the you for the or statement, that's fine. I don't mind writing the word or, which is weird because it's more writing, but I don't mind it, okay? But you're welcome to put a little you in between there to indicate that it's the union of these two, okay? Now, some of you noticed something odd about these two inequalities, which is good if you did. If you didn't, that's fine. The graph is going to reveal that what I've written right now for my inequality would have to get marked off points, and here's why, okay? So let's go ahead and graph these. So I got, there's 0, there's a 2 on the right because it's positive, -5 somewhere here on the left, just somewhere, okay? And I'll start with -5. So it says x is less than or equal to -5, so I got a closed circle there. Add -5, and it's not eating the x, so the line goes to the left. Okay, there's one of my graphs. The other inequality, x is less than 2, so that's an open circle of 2, but see this one also, this line also goes to the left, okay? Now based on what I'm seeing with the graph, I do not need both lines because it is an or statement, right? We can see everything to the left of pretty much and -5, and to the left of -5 here would make both of them true, but it only has to make one of them true because it's an or statement. So you could say, well, I'm going to go to -5 and then jump on the red one, and then I can go all the way to +2 here, and that's where it ends, right? So this interval would look more like it would go all the way to -infinity, and then it would stop at 2, which is not included, okay? Now, because it does look like this, and we've seen this type of inequality happen before, that means that the actual inequality to write for this one would be that x is just less than 2. Okay, so that means that I really didn't need either of these. Well, I mean, I needed them to graph, but I only needed one of them in the end because of the or statement. Now, you'll keep in mind, most of the time, these actually go in different directions, and that's where we use the u in between the two intervals. But since these went in the same direction, we have to be careful with what we're looking at. An or statement only has to be one or the other, but the and statement, if this was an and statement, this would have ended at -5 instead of at 2. So I'll box in these so that we know where the answers are. There's one answer. We don't need the or statement. There's the interval, and then the graph. I'm not going to box it in because I suck at boxing. So yeah, it's a good question. So on a test, on an exam, like if I saw something like this, I'm okay with it because it still represents. You've shown that through the inequality and the interval that you understand what's going on, and so. Some students are okay to be like, yeah, I'm going to erase this stuff right here, and that makes it look real pretty. But just by the way that you write your inequality and your interval will help me to understand that you know that even though you've graphed this, I'm not saying I'm going to require you to erase that and make it look all super fancy. Like fanciness is great, you know, classiness is awesome, but maybe I should be more picky. So, I don't see any distribution on these. That's okay. I mean, it'd be okay if there was as well. And, you know, I like to just start with one of them. So I'm going to just go to this -6x plus 7 is greater than or equal to 25. And just solve it. This is a two-stepper right here, so subtract 7 from both sides. I'll try to make that a little bigger. Subtract 7 from both sides. That's isolating the x's, right? So this gives me -6x. My 7 zeroes out just like we wanted it to, is now greater than or equal to 18. It's positive 18, but yeah, here we go again. We're dividing both sides by a negative, which then gives me that x, that negative is going to flip that inequality, so x is now less than or equal to -3. All right? So that solves that inequality, but now we have this other one. And just a little bit of extra work, not really too much, but just a little bit. So I'm going to do 2 principles of equality in one step here. Hopefully that's okay. I'm going to put my x's on the left and the numbers on the right. And the only reason I'm saying this is because I got x's and numbers on both sides of the inequality, right? Now you could put the x's on the right. It's not going to matter. You should end up with the same inequality one way or the other. But right now, the -4 it has to go because it's on the x side of things. So I'm going to have to add 4 to both sides. It's going to zero that out. I'm going to get 14. Also, I'm going to have to subtract 2x from both sides, because the x's are on those two x's are on the number side of things. So 3x's minus 2x's is 1x left over. And yeah, we'll just make that a phantom one. That's done right there. So now x is greater than 14. Now, because I don't know how the graph is going to look, I'm still going to put an or statement in between these two, just to make sure that if I need to change it in the end, I can get full credit and I won't forget that or statement. I'm saying that because I usually do. I don't know if you do, but I do. So now I'm ready to graph this thing. And so you see 0 right there in the middle, 14 would be way over here, and then I guess -3 somewhere in this area. Doesn't have to be exact when you're doing it by hand. And yes, you never have to do it by hand on canvas as far as I know, but whatever. So x is less than or equal to -3, so that's going to give me a closed circle at -3. It's not eating the x, so the line goes to the left. So that is that part of the graph. X is greater than 14. It's not equal to 14, so it's going to be an open circle, and it's eating the x, so it goes to the right. So that is my graph. So this is usually what our or statements look like, okay? They don't have to, just like we saw in the last example, but for the most part, they generally tend to look like this, okay? So what is my interval? Well, looking at the red line, I'm starting with the red line because it's furthest to the left. It goes all the way to -infinity, and then it stops at -3, which is included, so I have a square bracket. And then I will unite this with the purple line, so that's 14, but it's not included, so it's just a regular parentheses. That's going to go all the way to infinity, and that right there is the interval, okay? So since it didn't give us one of those unique scenarios, yeah, the interval's good, and then the original, I know the boxing here is kind of sloppy, but it works. But that's the interval, and also the inequalities, and then the graph there at the bottom. So just a quick hypothetical here. If that was an and statement, then our interval would be
none.
Yeah, it doesn't exist because there's no intersection.
So
there has to be
zero
some
here.
form of intersection. All right, here's one. Now look, you see that the inequalities are getting bigger. And so for those of you that are like, man, I love solving these inequalities, it just gives you more extra stuff to do. For those of you that hate inequalities, it gives you a chance to start liking them. Not that we really expect that to happen, but it gives you something to do. Why don't you guys take a minute and try this one out, okay? I can almost guarantee that I'm going to do the one on the right a little bit different than you did, okay? And if that is the case, that's fine. If you did it the same way that I do, that's going to be fine too. And I'll show you why here in a second. But I want to do the one on the left first. So let's solve this one on the left for x. And yeah, I'm still going to keep on this one. The x is on the left and then the numbers on the right. And then, well, that would mean, and again, I'm going to do 2 steps, 2 principles of equality in 1 step here by subtracting 5 from both sides first. So that will zero out the 5. And then the -7 minus 5 would be -12. But also subtract 6 x's from both sides too, okay? So that's going to give me 6 x's there, which is now greater than -12. Dividing both sides by 6. And be careful again, I just want to emphasize this. Some students in the past, even on an exam, they would see something like this. There's a negative, I got to flip the inequality. No, the coefficient is positive. It's not going to affect the inequality, okay? So -12 divided by 6 is -2. So there's our first inequality. X is greater than -2. Or, we got this other one. So let's do this, again, 2 principles of equality in 1 step here. And this one, though, I'm going to put the x's on the right and then the numbers on the left. And that's where the difference may happen between what I'm doing and what you may have done, okay? Why am I doing that, by the way? It's because I have more x's on the right than on the left. It's going to keep the coefficient positive, which means I won't have to worry about flipping the inequality in the end. Some of you may notice that when you're solving these problems. Some of you may not. It doesn't matter. You will end up with the same inequality either way, and I'll show it both ways. If you kept the x's on the left, you'll get the same answer. It's just shown a little bit different, okay? So that means that 5x has to be zeroed out first. Not really first, but at some point here. So that's going to zero that out. 14x's minus 5x's, boom, 9x's. And then that +7 has to be zeroed out. So -7 there, -7. Hey, that's nice. -20 minus 7 is -27. And this is all greater than 9x. See, so I now have a positive coefficient. I know now when I divide, I'm not gonna have to flip that inequality. And again, whether you do or not, you should end up with the same answer. So divide both sides by the coefficient to make the coefficient of x a phantom 1. Negative 27 divided by 9 is negative 3, which is now greater than x, okay? Now, if you had placed the x's on the left, once again, it's the same inequality, it's just shown a little different. It would have shown as x, still needs to eat the negative 3, right? So that'd be is less than negative, x is less than negative 3. This is the same thing. And between these, again, before I forget, I'm going to put the or statement between those two, okay? Then we'll see if the graph requires any further consideration here, okay? So let's see, where are these numbers? I'll put 0 here on the right. Negative 2 would be first, and then negative 3, something like this. I'm not caring about the spacing because I just want to know that they're in the correct vicinity of each other. That seems like a word to use right now, but whatever. X is greater than negative 2, okay. That's an open circle at negative 2. I'm looking at the red one. And it's eating the x, so this one goes to the right. Okay. Now, my purple one, I'm going to look at this one. Some of you, again, you're looking at the inequalities as arrows. If you do that, you have to keep the x's on the left. That's the only way that will work. But the way that I have done it, I've purposely put the x on the right. Not just to show you that you have to consider that, because you could always change it like this, but because it still works. So, negative 3, yeah, it's an open circle because it doesn't equal the x, but this one does not eat the x, so the line goes to the left. Okay, so there's my graph. And now I'm ready for the interval. So as far to the left as this purple line goes, that's negative infinity. It stops at negative 3, which is not included. So I have open parentheses there, close parentheses, that's better. Then we got the u for the union or the or statement, starting at negative 2, which is not included, so we get a parentheses there. This one will go all the way to infinity, very long ways away, but it's there, okay? And now I have the inequality, either this one or this one, by the way, and the interval and the graph. Not really in that order, but it still works. Oh, it didn't ask for the interval. I guess I didn't really need the interval, but I still feel good about it. Well, here's another one, and I'm sorry if it feels like I'm running through these, but, you know, we do have another section to cover on this, too, you know? All right, so right here, I'm going to start with the one on the left, so I got to distribute that 5. That's the 5 groups of 1x, that'd give us 5 x's. And then 5 groups of negative 1 would give us negative 5 right there. Now we still got the minus 5, and this is less than 10. And now, even with distribution, we still have some like terms to combine. So let's go ahead and do that. Negative 5 and negative 5 would be negative 10. So now it's 5x minus 10, and is less than 10. Well, got to isolate my x's, so let's get rid of that minus 10 right there by adding 10 to both sides. I'm kind of sticking with the same color here, just because we want to graph it with the same color, right? So I'll drop my 5x. This is less than 20 now. Well, that's a nice inequality to solve. Divide both sides by 5, and the coefficient here is positive, so that will not flip the inequality. Phantom 1x is less than 4, it looks like. And this one does want the interval. I'll try to keep that in mind in the end, even though I guess I did it anyways. This next one on the right. Now you see there's more x's on the right, but they're negatives. So I will, on this one, keep my x's on the left. Okay. So that means, well, I can still do 2 principles of equality in one step here, but I got to get rid of that plus 6 by subtracting 6 from both sides. That zeroes that out. 14 minus 6 is 8. And also, I'll need to add 6 x's to both sides here, okay? 2 x's plus 6 x's, 8 x's. Oh, this is going to set up very nice again. Coefficient is positive, so I'll divide both sides by that coefficient, 8. And it makes it a little bit smaller. X is now greater than 1. So here's my statement. X is less than 4, or x is greater than 1. This one's gonna give us a bit of a unique scenario, okay? And some of you that have perhaps graphed this already know what I'm talking about. But here we got 0, there's 1, and then 4 over here, something like this. So my 4, at 4, with the red one, at the open circle, because it's not equal to 4. X is not equal to 4 there in red, and it's not eating the x. So this line would go to the left. Some of you may not have drawn the whole thing. Like I said, sometimes students will just draw the line to here and just see what happens with the second one, you know. It's up to you. And then the purple one, x is greater than 1. So at 1, we have another open circle, and it's eating the x, so this one will go to the right. Well, this is an or statement, while the graph is usually what we would expect to see with an and statement, right, with some intersection right there. So again, we could say, look at our interval right here. How far to the left does this thing go? It goes to negative infinity. Now be careful because it does not stop at 1. It can just hop between the two lines here, but once it gets to 4, even it doesn't stop. It just jump on the purple one and go all the way to the right. So it'd be from negative infinity to positive infinity. I know I separated those. Hopefully that's okay. Now what does this mean for our inequality? It just means that instead of it writing it like this, we'd have to say that x is, I'd say an element of all real numbers. I'm trying to think how that'd go. X element of all real numbers. Remember that fancy R business? Something like that. It may have you, it should indicate what it wants you to do if it wants the inequality for that on the homework, okay? Like all real numbers, maybe it has a multiple choice kind of thing, which I think I've seen in the past. Now, in addition to that, though, the graph, because you wouldn't put two graphs on this one for the homework, okay? You'd need to show, since you've done this by pencil now, you see that it goes all the way from left to right, so just do one big line like this. You know, I'll try to make it bigger and prettier. There we go. See, it kind of
Good.
it's in there on this one, okay? But we don't want that to happen. However, everything's still solved as usual, just like we would an equation. So I'm going to start here on the left, and just isolate my negative 2x's, so subtract 5 from both sides. So drop my negative 2x. You could have zeroed out the 5s first as well, but whatever. So negative 2x is greater than 17 minus 5, boom, 12. Okay, and yes, this division right here of negative 2, coefficient, yeah, that's going to flip this inequality. So now x is less than negative 6. Now for and statements, we don't usually need two inequalities to represent an and statement. We only need one, which we will show hopefully by the end of this problem, okay? But that solves that first one there on the left. Next one here on the right, distribute the 3. 3 groups of 1x's would be 3x's, and then 3 groups of negative 1 would be negative 3 is less than or equal to 3. Well, solving for x, add 3 to both sides. Drop your 3x, that zeroes out. 3x now is less than or equal to 6. Divide both sides by 3. That's positive, so we don't have to worry about flipping the inequality. X is less than or equal to 2. Okay, now, again, we'll see what this looks like with the and statement, but I can't just put an and statement between these, okay? As convenient as that be. Let's look at see what the graph looks like. So what do we got? Negative 6 and 2. So there, 0's in the middle, negative 6 over here, and then 2 we'll say right there, okay? All right, let's start with the red one. Negative 6, that's an open circle because it does not equal that negative 6, just less than. And this one's not eating the x, so this line here will go to the left. And then the purple one, x is less than or equal to negative 2, so that'd be a closed circle at 2. And it is not eating the x as well, so this one goes, I'll try to do that a little bit better. I think that, I accept that. So we've solved it. Here's the graph, but there's only one part of this graph that you need, right? Because we're looking for an intersection of the two lines. And while I kind of draw them apart, I think of it more as where they become, I guess, parallel or where they overlap, right? However you want to think about that is completely up to you. But the real graph you'd have to have a circle right here and then just everything to the left. Meaning, really, that purple one is kind of obsolete right now, okay? And that also means that in terms of the two inequalities we found, we don't need this one. Because everything to the right of negative 6 would be a false statement for this and statement. It has to be not only true for one, it also has to be true for both. And it's true starting at negative infinity and then it stops at negative 6. Now, whether we use a closed parentheses here or a bracket depends on if this circle is closed. Because we know the purple one, at negative 6 is going to make this purple inequality true. But will it make this red one true? No, and it has to be true for both. So this is going to have just a closed parenthesis. So we get this interval, and then the graph would just be the orange line right here I kind of feel compelled to erase the purple line. Something like this, okay? So just the purple, and then the inequalities, x is less than -6. Now, for this first one on the left, I'm going to do this one just a little bit different than perhaps what you may be expecting right now. Some of you know this trick, and it only works as long as there's no other operations here on with the parentheses side, okay? And it could be on the right, it doesn't matter. But if I get a set of parentheses like this, and I not only see that the number's low that I'm distributing, but that the other number on the other side of the equation or inequality is a multiple of that number, I like to just go in there and just divide both sides by 3. Well, what the crap are you saying we can just divide by 3? It's a principle of equality. You can do it anytime you want. What does that do? It gives us a phantom 1 right there. Okay, so what am I left with? Well, it leaves me with the 5x minus 4. You can put in parentheses if you want. Like, if that makes you feel better, feel free to do that. But then I get this is less than or equal to, instead of a large number like 24, now I've kind of narrowed that down into 8. Okay, now you'll get the same answer even if you did distribution, okay? So if you're like, I distributed, and that's the way I like it, do it. It's not gonna affect the answer in the end, okay? But now, what this does for me, it allows me to deal with some smaller numbers, right? So I would say, let's go ahead and add 4 to both sides. Zero that out, so I got 5x that I dropped is less than or equal to now 12. And then divide both sides by 5. Okay, now again, some of you knew this already. Some of you didn't, and maybe still hate it. I don't know. You don't have to use it, but it is a method that you can use, okay? So in whatever you did, you should have still have gotten x is less than or equal to 12/5. That's what you should have got, okay? So if you used distribution, you would have had the same answer. It's just, let's see, it would have been 20 15ths or something like that. You just got to simplify it, whatever it was, okay? But that does solve that one. So let's go now to the right. And, well, no tricks here or shortcuts. Again, I'm going to put the x's on the right, though, and then the numbers on the left, because again, doing this is going to force that coefficient to be a positive. But you don't have to do it like that. All right, so x is on the right, numbers on the left means that negative 5x has to be zeroed out, so add 5x's, excuse me, to both sides. So that does zero that out, just like we wanted. And then we're left with the 12x's there on the right. But now that plus 11, it has to be zeroed out as well, so minus 11 on both sides. 5 minus 11, that'd be negative 6. So negative 6 is less than 12x. Divide both sides by the coefficient 12, and now I end with phantom 1x. Well, comparing this with, looks like negative 1/2. So negative 1/2 is less than x. Now this is an and statement, right? So let's look and see what this ends up looking like on the graph, okay? And then we'll figure out the interval. But right in the middle here, we got a 0. I'm going to put 12/5 way over here on the right because it's positive. And then negative 1/2, again, it doesn't have to be, when you're doing this by hand, it doesn't have to be proportional. But something like this, right? So my 12/5, I'll do this one in red. It's a closed circle because it actually does equal to 12/5. It's not eating the x, so I'm going to shorten this line to the left, which is kind of on purpose, which hopefully we'll see here in a second. And then the 1/2, negative 1/2, open circle, but this one's eating the x, so this line goes to the right. Now you could extend these. You could say, well, I know then that the red line would go all the way essentially to the purple line, or the purple circle, and then the purple one would just go all the way to the red, because we're looking for an and statement. This is the only area where it would make both inequalities true. Anything on the outside, right, according to the graph, anything to the left of negative 1/2, false, including negative 1/2. And anything to the right of 12/5 would also give us a false statement. So that's the graph. And again, when you put this in on canvas, you're going to have the open circle, just one line, and then the closed circle right there. All right, so on this next part, so I got the graph in green, but neither one of those inequalities is going to work. And you could say, well, couldn't we just put an and statement between them? No, well, this is where we need that compound inequality, right? So we're looking at an x value. See how it's sandwiched between this, I guess, negative 1/2 right there. And then also the 12/5 here on the right. So you see that it needs to be greater than the negative 1/2, but also it needs to be less than or equal to the 12/5. Why is it, how do we know it's less than or equal to? Because it's a closed circle at 12/5. And why is it just greater than the or why is negative 1/2 less than the x? It's because we know it's an open circle right there from the graph. Okay, so that's the actual inequality that we would need for a problem like this one. And then the interval, pretty much the same kind of thing. Starting at negative 1/2, that's where the interval would start. It's not included. And then it would go all the way to 12/5. Sorry, different color. 12/5, which is included, so we get a square bracket like this. Yeah, so on this one, principles of equality, and again, right here, we couldn't use the same trick we used on that last one where I'm just going to divide both sides by 3. I mean, you could, just you have to be very careful doing that. So I'm not recommending, okay? But this one here on the left, let's go and solve it. And I will use distribution. I know some of you know that you don't have to, but you could. I'm going to, okay? So I'm going to distribute my 3 into the x minus 3, so that'd be 3 x's. And then 3 times negative 3 is negative 9. Nothing else really changed right there. So some technology here. But now I do have some like terms to combine. Negative 9 and positive 12 would give us positive 3. So now it's 3x plus 3 is greater than or equal to 18. So subtract 3 from both sides. To zero that out, drop your 3x greater than or equal to 15. And 15 is a multiple of 3, so it's going to turn out very nice. Divide both sides by 3. X is greater than or equal to 5. Okay, so there's our first one. And we have this other one as well on the right. So we'll do this one in purple. 2 principles of equality in 1. I'll put the x's on the left because I have more on the left and then the numbers on the right. So minus 6 from both sides to zero that out. 2 minus 6 would be negative 4. And then I'd have to subtract 4 x's from both sides as well. So that'd give me 1x. And remember, the idea with the last step in solving equations or inequalities is to get the coefficient to be a 1. So I'm just going to make that a phantom 1. So that's it right there. That is the inequality for that, I guess, overall inequality. Okay. Now again, before I put an and statement, let's see what the graph looks like. So here's 0, negative 4 on the left, and then 5 here on the right. I'll start with the red one. X is greater than or equal to 5, so that's a closed circle of 5 going to the right because it's eating the x. And then a negative 4 open circle, this one's not eating the x, so it goes to the left. Now again, for an or statement, this would be good, but this is an and statement. So is there any indication on this graph that it would be true for both? No, because the lines don't intersect. So, I'm just going to put a big DNE on this one because it's the empty set, right? This doesn't have any solutions that would be true for both. I don't think that's super tricky, but, it can throw us off sometimes because it's like, well, they don't intersect, so it has to be an or statement, right? No, don't get caught up in that. You have to think of this in terms of the and. If you really understand that, then you know pretty quick that that's a DNE, which also makes solving this go a little bit faster too. This right here is what we call compound inequality. And I think we've seen this. I mean, we saw one that was like that for one of our solutions as the inequality. But here's the way these compound inequalities work, okay? And, I guess I should start working with something a little bit less abstract. So if you look at a compound inequality, one that doesn't require so much work, just to help us understand this, right? So we'd say x is, let's say that it's greater than, I don't know, negative 5. But maybe it's less than, I'll just do less than 10, okay? Now, you should be able to think and look at this one and think, well, what values of x would make this a true statement, right? Because what you have here, especially if you were to put this on a graph, is you got the values of negative 5 here on the left, and then you got 10 here on the right, 0 somewhere in the middle over here. Not that that matters. But we can see how x is kind of sandwiched between these. Not just that it's sandwiched, but it's bigger than the negative 5, so that would be to the right of negative 5. But it's also less than 10, so that would have to indicate that it's got to go to the left right there, right? You'd have open circles here with the line in between. So it's kind of like representing an and statement for us, okay? Which means that this compound inequality could be broken up into 2 separate inequalities. The first one being negative 5 is less than x, which we did graph there in purple, kind of. And then the second one where x is less than 10. But again, it becomes what we would consider an and statement between the two, okay? Because we're looking for the intersection of those two. But we can, just like we did with that example, we kind of compressed it into one, I wouldn't say really bigger, but more convenient inequality right here, okay? Now, this means that when you're looking at compound inequalities like this, you can break it up like I just did right there, and then solve it like it were an and statement, okay? But we can apply principles of equality not just to two sides, but we can do it with three sides. So back to this problem, right? So you could write this as two separate inequalities. The one on the left would be -3 is less than or equal to x over 2 plus 1. And then the one on the right, I'm not going to do this, by the way, because I think it's better if we can get the other way. X over 2 plus 1 is also less than or equal to 5. So you could just solve these two. And since you love solving inequalities, yes, I'm being sarcastic, but you could have as much fun solving these as much as you want twice, okay? But here's the thing. If you did this, you'd notice, first thing, that you'd subtract 1 from both sides up here, like this, to zero out your 1s, right? But you would end up doing the same thing to this one, right? Subtract 1 from both sides, and then you'd have your principle of equality taken care of. What I can do is I can apply that to the current inequality by saying, look, I subtract 1 right here because I'm trying to isolate the x's still. Remember the lines like this? But now instead of doing it to two sides, I got to do it to 3. Oh, dang it. There we go. Okay, so I can apply these principles of equality to 3 parts of an inequality like this, okay? So what am I left with? -3 minus 1 is -4. Of course, that's zeroed out. So I do drop the x over 2. And then 5 minus 1 is 4. So the inequalities don't change because we didn't have a negative coefficient. And now, to solve this inequality, I just want the x in the end. And I don't want to divide by 2, so I'm going to multiply that by 2. So multiply everywhere by 2, all parts by 2. So 2 times -4, that's -8. And then 4 times 2, there's +8. Okay, so x, -8 is less than or equal to x, which is less than or equal to 8. Okay, I guess, oh, they did want this in inequality notation, so actually that's as far as we need to go on. Oh, as far as we need to go on this one. All right, here's this one. So this one does want the interval, so I'm gonna put this on the graph just because it makes things, I think, pretty convenient. You don't have to. But yeah, look, we got 3 parts to this, right? So I've separated into 3 parts. Whatever I do to one of these, I have to do it to all 3 of them, okay? And the first thing I'd want to do is isolate my 3 x's right here. Just want those 3 x's to be by themselves. I don't want that -5, so add 5 to both. Well, not both, but all 3 parts. Okay, to zero that out, which is kind of our first goal, -2 plus 5 is 3. 7 plus 5 is 12. So 3 right now is less than or equal to 3x is less than 12. And then divide all 3 parts by the coefficient 3. That's phantom 1. Phantom 1x. 3 divided by 3 is 1. 12 divided by 3 is 4. That was a positive coefficient, so all of our inequalities stay the same, okay? So there's our inequality. And again, you can kind of transfer this directly onto a graph. I guess I got to do this by hand. Not that anyone wants that to happen, but here we go. So the lower number should always be on the left. So the 1, I'm just going to put right there, and then the 4 right here, okay? And I don't really care about the scale, but x I can see is sandwiched between those two, so it should be something in between, everything in between. But now comparing the values with x, 1 is less than or equal to x, so I get a closed circle of 1. And then at 4, it does not equal to x, so that's an open circle right there. See? And again, you could have split this up into 2 separate inequalities if you chose to. You could have said, well, 1 is less than or equal to x. And then over here, that would have been x is less than 4. With an and statement, but if we can make that a compound inequality, it just makes that a little bit faster. Now, the graph, of course, just to help us to get to the final answer, which is the interval. And so starting at 1, which is included, this would go all the way to 4, which is not included. So in the end, this is actually our final answer. Now, you could use that trick where you say divide by 2 on all 3 parts on this, but it's gonna give us a fraction, which I don't really want right now. I mean, you're welcome to do that if you'd like. You end up with the same answer. I'm just not gonna do it right now. I'm gonna distribute the 2 into the parentheses. So that'd be 2 times x, that'd be 2 x's. And 2 times -3 would be -6 right there. So everything else stays the same. -3 is less than 2x minus 6, less than or equal to 4. And now I will add 6 to all 3 parts. Here, right? So add 6 plus 6. Hopefully I have enough space. So that drops the 2x just like I wanted. And then -3 plus 6 is 3. So 3 is less than 2x, which is less than or equal to 10. Finally, dividing all parts by the coefficient 2 tells us that x in comparison here with 3 halves would be greater. But compared with 10 divided by 2 is 5, that'd be less than or equal to that, okay? So that solves the inequality. It does want the graph and the interval for this though, okay? And while I didn't center that, it would be perfectly fine if you're doing this by hand, just to have these where I have them. So that'd be 3 halves right there, and then 5 right here, okay? You can make that look more pretty if you'd like, but x has to be everything in between these, okay? So everything in between, sandwiched between. It's an open circle of 3 halves because it's just, it's not equal to x. And then at 5, that would be a closed circle there because it does equal to 5, okay? So there's the graph. And then finally, the interval starting at 3 halves here on the left, which is not included, so that's an open parentheses. Stops at 5 here on the right, which is included, so that'd be a square bracket right there. So now we have the inequality, the graph, and the interval. Boom.